Okay, other things you should know is that in CS Awesome, I've posted the Unit 2 and Unit 3 assignment. And just to review that, because I know some of you are working on Unit 1 right now, and you're working through the entire unit, and that's not required of you. Parts of the units are required. So you go here into Unit 1, you see you have all these things. I only assigned like the first half or so, and it's just for you to read through. The other parts aren't required. How do you know what you're assigned? You click on your face, Assignments, and then click here, Unit 1 Assignment. Be sure you're clicking here. Also be sure that you're seeing lol-chan 2020 to 21. That's really important too, so your progress is saved. Because I noticed some of you in your reflections are writing that I'm working on the pre-test or the post-test. Like, that's extra. That's not required of you. Alright, so go here and answer these exercises. And it looks really much the same for Unit 2 and Unit 3, except there's like more content. Okay, that makes sense? Alright, and if you need more time for any of these things, just let me know. We're flexible with due dates, especially during this time of distance learning. Okay, double check the time, 9:06. On to today's lecture. So today and into next week, we'll be covering the first 3 units of CS Awesome, and that serves as your like programming review and Java specifics lesson. And then beginning week 3, Mr. Simon and I plan to start like hopefully some brand new content, let's say, for AP CSA. For today's lesson, we're focusing on these first 3 ideas: variables and types, declarations and initialization, and modulus and integer division. Next week, we hope to get through at least these 5 topics down here, and you can get a head start and read through units 2 and 3 about these 5 topics. Think of these first 2 weeks as like a Java boot camp to get you up and running. I already mentioned this. In CS Awesome, be sure you're in a specific class. Mine, lol-chan 2020 to 21. Mentioned this already. I auto-graded, I think last night, no, 2 days ago, no. Yeah, I graded once, and your scores haven't been auto-graded by me since then. So I'll do one more auto-grading when it's due this weekend. In terms of points, be careful, because sometimes CS Awesome tracks your interactions on the page. You have to click on links, watch videos in order to get all the points to get this green bar to move to completion. And perfect score as of right now is either 45 or 47. There are some questions I have to manually grade. So right now it's 9:08. We end class is 35. So someone at 9:25ish, give me a warning either in chat or unmute yourself. We do have a Kahoot at the end to review the ideas talked about today. So you've learned from 4.4s that for sure Java is picky. You've also learned that capitalization is important. Some smaller details that you may not have noticed was curly braces, these little things in yellow. For your 4.4s program, the skeleton was already there. You already had some code given to you, and you were, for the most part, writing in the same spot. A tiny detail is some of you, if you wrote code like in between these lines over here, where my pointer is, or over here, your code wouldn't have ran. You would have gotten an error, and that has to deal with where, like these specific functions. We'll talk about classes like in the next month or so, but this is your main function. In JavaScript, if you're with me last semester, that was like the draw function. That's where all the stuff happens. That's where programs start. Okay. And then semicolons. Large majority of us have come from languages that don't use semicolons, or semicolons are optional. That's not the case in Java, so I'm sure you got this many, many times, and I constantly miss my semicolons too. Here's another new idea for Java. Java requires types, so it's a strongly typed language. JavaScript and Python uh, don't, or they're what, weakly typed? Forgot the exact word for that, but they can assume what kind of variable you need in the moment. But JavaScript or Java can't do that. So you have to tell it exactly what you need. And so things that we've encountered so far, like int, stands for integer, um, and there's some couple more data types that we'll go over. And the analogy I want you to think about as we go into like type variables and data types is think about parking a car. Some of you are of age to drive soon, so this will be relevant. If not, at least you've been in a car and you've parked in a spot before. Or been in a, yes. So variables, it's the vehicle, yes? The data that lives inside the vehicle, you, the person, the cargo, that's the data. The brand of the car, let's say, or the physical shell, that's the data type. When you go into a spot, right, it has a name. So in this case, you see down here, this parking spot's name is G210. That's useful because later on, when you parked your car there and you've done your thing, you've left your car, you come back, you need a way to refer to it. You know that parking spots come in all bunch of different sizes, and so do variables and data types. You have really big ones, really small ones, compact cars, so on and so forth. Another analogy you can think about while working with variables is since like programming language is similar to English, right? English we've been using for a really long time. So in English, we have like nouns, verbs, adjectives, and adverbs. They have a certain usage. They belong in certain places, and it's like a category. Yeah. So that analogy you can carry over too. When you play the Mad Libs game, it asks you for certain requirements, and then you decide what to put in there. So in this sense, the data types are given to you, and you fill in the data, right? So back to Java, you can carry those analogies to help you make sense of it. So data types, right? Int we are familiar with. Floats and doubles, these are decimals. Boolean, we'll see those are true and falses. Characters, or char, which is short for character, is letters. We'll show examples of each of these, but these are the 5 you'll need for the AP Java test. They're also called primitives because those are the most like basic data types. And so, to be even more specific, integers, they're whole numbers. They can be negative, they could be positive, and this is, I think, the smallest an integer can be in Java, and this is the largest an integer can be in Java. Floats, those are decimals. There's a decimal point located somewhere, and it only holds up to 7 digits after the decimal point. If you need something longer, then you have a double. It has double the amount of digits after the decimal point, so that's where it gets its name from, and it holds up to 15 digits. Booleans, think back to geometry class, truth tables, which we will talk about and review next week. Booleans are either true or false, yes or no, 0 or 1. And then characters, they often are thought about as letters, but they could be numbers, they could be spaces, or they could be punctuation marks. Those all count as characters. If you press something on the keyboard, it's likely tied to a character. Or sometimes you have those weird ASCII characters that are tied, like the @ sign, shift 2, right? That's a character. And all those special things. We'll be using, I think, mostly these 3 for now. We'll move into Booleans next week. Characters, let me think. Characters aren't really used that much. Java has the string class, which does a lot of word and character manipulation for us, so we won't see this that often. Okay, back to variables. There are two important steps for making variables. The first one is declaration. Okay, you need to tell the computer what kind of data type you need. So that's int, float, double, boolean, or char. And then you need to give it a name, like in the parking spot. In this case, we have an integer named num. Also know that there you like constantly semicolon, semicolon, semicolon. That also is required. So that's your first step when making variables, declaring what you want. Names, specifically to Java, they have this a certain amount of rules, right? So variable names can't do these things. They can't start with numbers. They can't contain a space. And then some words have special meaning. So you notice if I try to type like int class, and in whatever editor you're using, for Horse it was trinket, it's going to change colors. The colors denote that Java has already reserved those words. It means something already in Java, so you got to pick something else. You can Google the list of 50 or so reserved words. Some of these reserved words you've seen before: class, static, void, int. Another example is like illegal is like if you go int semicolon. So a little bit more about variable names. You want your variable names to be descriptive, right? Like if you called everything X or everything Y or everything Z in math class, that's going to be really confusing. So you want to give a little descriptor on what a variable represents, like Fahrenheit temp or temperature or dollars earned instead of X, Y or like XZ or whatever it is. And as names get longer and longer, there's a certain kind of way to style it in Java, and that's with camel case. So camel cases start with lowercase, and then every other word, or every word after that, begins with a capital letter for each new word you see. Like here, first name, number of dogs. You see where it's strategically capitalized? So it's just a naming convention that's very common. Other things you can Google is like snake case or Pascal case, and it's surprisingly they all have names in computer science. And because Java is space sensitive, these variables are all different compared to one another. Okay. So as you look at this slide, we've done the declaration step here. My pointer is working. There it is. Oops. We've done the pointer step in. We've done the declaration step in line 6, int num. And here's a familiar line of code: system.out.println. When we run this code, we expect it to work, but actually it tells us this error: variable num might not have been initialized. So that's the next part that we have to do when working with variables. First comes initialization, or first comes declaration, then comes initialization. Initialization is the act of giving a variable, whatever type it is, its starting value. So right here in line 7, notice that first we declared, then we initialized. Initialized, you use the equal sign. We call it often the equal sign because we're familiar with that in math class, but in programming, we call that the assignment operator. And what that's doing is it's putting the number 3 into that parking spot, right? 3 is the car. It goes into the parking spot called num. Now when we print it, we see the value 3. So it seems kind of tedious if you always want to separate them. You can combine them into one single line of code versus 2 lines of code. So on the left here, you have the declaration. On the right, you have the initialization. So keywords to remember for initialization is assignment or setting certain variables to their initial value. So these are 2 vocabulary words you'll need to remember. You can do both at the same time. Begs the question, can you initialize and then declare the same variable? Answer there is no, because if you refer to a variable that hasn't been declared yet, then it tells you like, what are you referring to? I don't know what that is. Okay, floats and doubles. Here's a quick example that shows you the difference. you divide some things. 5 divided by 9.0, notice the 0.0 there, and it produces this output, 5, and then a 6. So notice some rounding happens here. Then the float version, we'll talk about this next week. This is called casting, but it makes denum, which is originally of type double, into a float, just so we can show you the output. So floating point, float is short for floating point, the point being the decimal point, as it can be in different places. Double, it's just digits, right? The name kind of speaks for itself. We'll come back to some of these ideas, and sometime next week we will come back to like some arithmetic between floats, ints, and doubles, and mixing them up. Okay, another short program. If you zoom in, you notice down here we're trying to print a certain number, and then it tells you, this number is way too big. This is way more digits than the first number I showed you on the previous slide. Okay, did I talk about what I needed to? Assignment. Okay, so initialization is just a fancy word for the first time that you use the equal sign. From all the other points afterwards, it's just called assignment, right? You set the value to something else. So as we make our programs more complicated, lines 9 and 10 are what's new in this program. Notice that once we've initialized it in line 6, once we've declared our integer num in line 6, we've initialized it in line 7. You wouldn't call line 10 another initialization. This is just called an assignment. So we're assigning 5 into num. And we see each time we print, those are its value. It gets overwritten. Strings. So those are words. We'll go into this in detail. Strings, notice the capital S. That's actually important here. Just like how S in system is capitalized, these are referring to actually objects in Java. So string is an object. It's like a really fancy variable that has not just data tied to it, but functions and specific behaviors. For the time being, like string, you notice wasn't a part of the list of 5 primitive or basic data types, and that's why. Strings are actually objects. But for now, if you ever wanted to print out words or sentences, numbers, letters, punctuation marks, a bunch of them strung together, hence the name string, you'll have to do something like this. Capital S string, the variable name words, I like Java. And again, because these are literals, you want the words I like Java to appear, you need double quotes there. Very interesting error. You would think this would work, right? Because I think JavaScript or even Python, this could work, but Java's a bit dumber compared to those languages, in quotes, dumber. So you'd, in order to store the number, the string 5 in there, you needed double quotes, right? It's going to be a type mismatch. On the right-hand side, you have an integer, 5, because there's no quotes there. And on the left-hand side, it's expecting a string. Okay, so operations, I still got like 2 or so minutes. That's enough time. You'll get lots of practice with modulus in the Kahoot. So we talked about these 4 in 4.4s, or you've used them, less so me talking about them. Math teachers got to do that already. I get to tell you about modulus, also known as mod, also known as modulo. And that is unique to computer science, although math uses vary. Computer science is really like mod. And that's the remainder function. You've seen this before. In grade school, whenever you learn long division or any kind of division, here we have 8 divided by 5, right? Goes into there once, do some subtraction. When you do mod, which is represented by the percent sign, it gives you the remainder when you divide two things. So 8 mod 5, what's the remainder? Or 8 divided by 5, what's the remainder? It's 3. That's what this new expression is asking you. We read this 8 mod 5 from left to right. Mod is the remainder. Yeah. I kind of want to skip over this for time purposes, but just know that when you divide, when you mix up integers and decimals, you get different results. And you can review this slide in detail and notice the patterns there. Okay, back to mod. So in this first example, 25 divided by 5, what's the remainder? That's how I read these things. Or like if you want to be fancy sounding, 25 mod 5, what is that? It should be 2. Yes? Think about it as going around. Here's a helpful analogy. Mod is like clock arithmetic. So you remember, like your dial in your clock is 12, right? So you like go around the clock how many ever times, and wherever you stop is your answer, right? Is there a 12 example in here? No. So you, like 21 mod 2, you spin around your 2 like 10 times and you're left with 1. That's where the minute hand would be, for example. So that's your remainder. For these examples, 8 divided by 5, right? It doesn't fit in evenly at all, so it's 0. The remainder here is 5. And for even complicated problems like that carries through, like in this first one, 24 mod, a number way bigger than it. You don't, like, once you notice that pattern, you see that, oh, the remainder here is just 24, because it doesn't fit in any times. Thank you for the reminder, Adam. We will start the Kahoot. I have it on another tab. So do you want Kahoot music? Should I reshare my screen so that you hear it? Yes? Okay, no. um, yeah, let's see what happens, because the previous class kind of complained that they didn't get music. So I'm going to reshare my screen. Stop share. Share again. If your teachers ever get stuck on sharing computer screen, just tell them in Zoom, in the lower left-hand corner, you gotta share computer sound. Okay. Whoa. So does this work if there are previous players? I think I clicked on the link from last class. They're all ghosts. Can you all join this one still? Yes, no? Anybody? It's stuck. Oh, I gotta start it up again. Okay. 1 second. You can't see the code. Interesting. Okay, give me a moment. Oh, that's loud. Yeah, I'm thinking I don't want to share the music because then you all have to hear it too. 1 second, 1 second. Let me turn this one off. Let's see, Kahoot. Alright, some of you seem to like the music, others not so much. That's fine. So, how's this? Okay, I think I got it. So, no music this time around. Only I have to listen to Kahoot music. Oh, sorry. Yes. Wait, how did I hear that? If you weren't in my room, how did I hear you ask to be added to my room? Okay, there we go. Okay. I think there's 11 or so questions. They're about 20 seconds each. I think I'll comment minimally on these. I'll give you, I think, 1/10 of a point extra credit for the winner as some motivation, which I think is important for block 1. Double check, there's 36 people. You got like 20 more seconds to join for those that want to play. If not, then just look on and try to answer them in your heads. All right, 10 more seconds. Last person. Oh no, is that me? Yeah, it's me. Okay, we'll start. Go. Neat. For those that picked int, that would work if it was whole numbers. String could work too if it was listing out like sentences. Boolean, not so much. Cool. So you notice like Java does integer arithmetic differently. Yeah, it chops off whatever comes afterwards. You'll get more practice. I don't blame you because I skipped over that example or in the slide. My bad. Hmm, good. Majority of people got it. It's remainder, yeah? Maybe. So do some long division. What's the remainder? Ah, blast. More years of George Bush. Very good. Anita Bath is a string. Good. No one got fooled this time. Integer division gives you an integer. Nice. Uh, 21, not 22. 22 mod 10 would be 2. Notice false is bolded. Yeah, good job. No comments there. Right, so even if the numbers are less than 0, integer arithmetic is chopping off decimal places, yeah? So for those that thought, which one? Yeah, blue, it should be just 0. Nice. So this one's a little tricky, right? 7 doesn't fit, or 9 doesn't fit into 7 at all. So you have 7 as your remainder. When I first learned it, I wrote things out by hand. That way I would have it all straight. Yep, so both the initialization and declaration step are happening. I think we got one more question. Right. Yeah, exactly, Wilfred. Hmm. You're seeing the patterns. When the right hand side is much bigger than the left with mod, it's always going to be just a left number. Okay, so good job, you sustained. Hard life, good work. Okay, so the student with George W. Bush, take a screenshot, email it to me. You get 1/10 of a point extra credit. That's it for class. Take care. I held you a little bit later for block 2. Sorry about that. Go on to your asynchronous class.